Hello and welcome to the videos for 8.6, Solving Radical Equations. This section is considerably shorter than the last sections. The complex numbers is always a super fun topic, but at the end of the day, it's almost an entirely different topic. Let's go with equations. So up until this point, we've had radicals and dealing with how to simplify them, how to deal with variables inside the radicals, maybe taking them out, but we never really solved anything. So here we've got a radical equation. A radical equation is considered a radical equation if it has a radical within any point of the equation. So you're basically looking at it. These are all our square root equations. Luckily, it's just another step in solving equations. If I had square root 3x plus 4 equals 8, the first thing I want to do, well, the goal entirely is to get rid of everything around the x, move it to the other side in some way so that I can figure out what the x is, right? That is still the goal. It will always be the goal in solving equations. How do I get rid of the thing that is farthest from x here? The thing that is farthest from x here is a square root. When we want to move the 4, we use subtraction. When we want to move the times 3, we would use division. Here, what's the opposite of a square root? We're going to square both sides. Always use that opposite idea. So I'm going to cancel this square root with a square. Now be careful. You're not going to keep that square. Many people also just like give it 2 squares. Don't do that. What's left is underneath the radical. It's now just a 3x plus 4. The square, the new squared item, is actually on the other side. Here we have an 8, 64. 8 becomes 64. Next, we'll move the 4. We get 3x is equal to 60. Divide by 3. We get that x is equal to 20. Fabulous. All right. Do a quick check. This says be sure to check for extraneous solutions. Remember when we were talking about rationals, sometimes you would get an answer like x equals 2, and you couldn't put a 2 in the denominator because you'd get 0. Sometimes this happens with radicals as well. So let's do a quick double check. Square root of 3 times 20 plus 4 would be the square root of 64, which in fact would be 8. Check. And you're welcome to do that part in your head. You can just make sure that you get the correct answer. Okay. But again, that means our answer of 20 is valid. Let's try it again over here now. This time, when solving, the radical is actually not the farthest thing from Q. Instead, the farthest thing from Q here on this side is the plus 3. And so I'm going to move that with a minus 3 to the other side. So I have the square root of 5Q minus 1 equals negative 3. Now what would I do? I'm going to go ahead and square both sides. And I end up getting 5Q minus 1 on one side and 9 on the other. Go ahead and plug that in. I'm sorry, not plug that in. Add 1 to the other side. We get 10. Divide by 5. We get 2. Our answer would be 2. But let's go ahead and double check that real fast. Let's do 5 times 2 minus 1 plus 3 equals. That would be 10 minus 1, which is 9. The square root of 3 plus 3. Interesting. Does not in fact equal 0. And so this is an extraneous solution. There actually is no Q. Now, why did this happen? There was actually something that notified me that this wasn't going to work within the first couple steps of the problem. Obviously, if you miss it, that's a problem. So don't ever not check for extraneous solutions, okay? Because you can very easily miss them. But something did notify me after years of doing this. I looked right here. I said, wait a minute. The square root of something equals negative 3? Square roots aren't allowed to equal negatives. That makes no sense. And so there was this feeling I had that maybe this was doomed from the start. This was supposed to end up being a negative 3. Do you see that? Negative 3 plus 3, in fact, does equal 0. But because we squared it, we got rid of that negative part, and we basically broke it. Okay, we didn't break it, but the math broke it. Okay, so it doesn't work. Our answer actually would be D and E. Let's do another one. Over here, I've got the square root of 4 minus x equals x plus 2. Little harder to go with that find the thing that's farthest from x mentality here, right? I do want to get x to one side. To do that, I do have to take care of the radical first. So let's go ahead and square both sides. right? Not each thing, but make sure you square both sides. 4 minus x here. Remember, this would end up being a binomial times a binomial. And we'd end up getting x squared plus 2x is 4x plus 4 on the other side. So a little bit bigger. Now I want to get x to one side, so I think I'm going to go ahead and add x and minus 4, add x and minus 4. We get x squared plus 5x. Those end up canceling out. All right, now we're going to add another level. This is a quadratic, but luckily I see I can factor out just an x from both of these, and I have factored it. So it's an easy to factor quadratic, which means I split it up into x equals 0 and x plus 5 equals 0. I've got x equal, oh, well, I guess I don't need to solve that one, huh? X is equal to negative 5. So I've got two answers here. Let's check them real fast. 4 minus negative 5 would be 9. And negative 5 plus 3 does not, in fact, oh, no, wait, hold on. Plus 2, pardon me. Square root of 9 does not equal negative 3. So that one is a garbage answer. We've got the square root of 4 minus 0 is 0 plus 2. Square root of 4 does in fact equal 2. So it looks like in this case, one of them works, the other one does not. I would say always be wary of negatives, but you know, sometimes they work out. Sometimes negatives are okay. All right, let's do another one. We'll go over here. In this case, I have radicals on both sides, and I want the x's on one side. To do that, I got to get rid of those radicals. So I'll go ahead and square both sides. Over here, be very careful. Here you end up with 4x, not 2x. The 2 is not under the radical, so you get 4 and an x. Here I get 3x plus 4. Oh, that was kind of convenient. So notice more radicals doesn't necessarily mean harder. Move the 3 over. Whoops. Oh, cool. I get x equals 4. Lovely. That was easy to find. And then 2 times the square root of 4 is equal to, hopefully, 3 times 4 plus 4. This would be 4, because 2 times 2 is 4. Here, I've got 12 plus 4 is 16, and 4 is, in fact, the square root of 16. So that one is fine. All right, in the next video, I'm going to show you some tougher examples, kind of building on these guys here, some more crazy things that could happen. I'll see you in the next video.